Welcome back everyone to a new episode of the series. Today we're starting a major industrial project, the design and construction of a full iron mining, processing, and steel production complex. But before that, in the opening shots, you can see the helicopter platform that I built in the meantime. This is where our construction office will now dispatch workers directly to building sites, which will greatly speed up large-scale projects like this one. If you like the videos, don't forget to like and subscribe. Now let's move on to the main part. Before we begin designing the complex, the first step is preparation. Fortunately, there is a suitable iron ore deposit very close to us, which will save us a lot in terms of infrastructure. In the future, we will need to upgrade the existing road to allow for faster traffic flow. We ordered terraforming machinery early, so it can arrive exactly when we need it. Planning ahead like this prevents delays later, especially for heavy industry projects that require large terrain adjustments. Next, we start searching for a suitable location for the iron mines. The goal is not just to build a mine, but to build a mining complex capable of supplying 2 steel mills. Because of that, a single mine will not be enough. We'll need 2 separate mines working together to reach the required production. To estimate production, we can use a simple formula. Each worker in a mine produces up to 4 tons of raw ore per day at 100% resource quality. With a maximum workforce of 250 workers, one mine could theoretically produce 1,000 tons per day, but that only applies if resource quality is perfect. In our case, the deposits are not equal. One mine has 75% quality, and the other has 45%. That means the realistic output will be scaled by those percentages. So instead of simply doubling production, we have to calculate each mine separately. So together, our 2 mines can realistically produce about 1,200 tons of raw ore per day. Raw ore is only the first step. To be useful, it has to be processed. One ore processing plant can handle about 225 tons per day, and after processing, the output is roughly half of that as refined material. So in practice, you can think of it as roughly a 2-to-1 ratio between raw ore and processed output. A single steel mill requires about 200 tons of processed material per day, which means to fully supply just one steel mill, we already need 2 processing plants. Since our long-term goal is to support 2 steel mills, this mining complex needs to be designed with expansion in mind right from the start. Another important detail when planning layouts like this is conveyor capacity. One conveyor line can transport up to 600 tons per day. If production exceeds that, multiple conveyor lines or alternative transport methods become necessary. Ignoring this limit can easily create bottlenecks, even if your mines are producing enough resources. In this case, we have 4 factories with an output of approximately 100 tons a day, which means that we have about 200 tons until we reach the conveyor limit. Overall, we can conclude that before we start doing something, it is good to do the math first so that we don't wonder later why it didn't work out. And now I leave you to watch the rest of the complex's design. Keep in mind that these are only the main buildings, but then a lot more work will be needed for the rest of the infrastructure. We begin this phase of the project by placing the railway station in the center of the complex. This positioning allows workers to reach every industrial building from a single transport hub. Centralizing worker access like this reduces travel time and keeps productivity stable, especially in large industrial zones. After a bit of terrain leveling, we move on to the railway layout itself. The first track we design is the connection toward the future city nearby. This is also the direction of the border crossing, so this line will eventually become a very important logistics route. Since workers may eventually travel from here, I am making the line double so that more trains can travel at the same time. Since this place is the furthest from the factories and at the same time quite flat, I plan to build a small town in future episodes. It will probably not fully satisfy the complex's labor needs, but it will still be a major source of manpower and a guarantee of continuous operation of the facilities. While that line is being planned, we start positioning the 2 steel mills that this complex will support. Because space is limited, every structure must be placed carefully. On one side, we have the mountain. On the other, there's a river. That means the entire industrial layout has to fit precisely between natural obstacles. So during construction, some elements are adjusted on the fly and slightly repositioned to make everything fit together efficiently. This kind of adaptive planning is often necessary when building large complexes in restricted terrain. At this stage, both steel mills are connected using conveyors and rail links. For now, my plan is to supply coal to the steel mills using their built-in rail connections. However, this is only a temporary solution. Later in the project, I'll redesign this system for better efficiency. So stay tuned to see what changes and why. Toward the end of this segment, we return almost entirely to railway construction. The plan is to keep this line single track for now, while still leaving space for a future upgrade. At the moment, traffic demand should remain low, so building a full double-track line would be unnecessary and too expensive. Designing infrastructure with expansion in mind is usually better than overbuilding too early. The biggest obstacle for this railway is the river crossing. It's very wide, which means we'll need a long bridge, and long bridges take time to construct, especially when resources must be delivered over distance. So this section will become one of the longest construction steps in this phase of the project. The new railway branch will connect to the main line just after the exit of the coal complex. This position keeps the junction close to an existing logistics hub while minimizing extra track length. One interesting design choice here is the addition of a waiting track near the junction. This extra rail segment acts as a buffer. Trains can stop there without blocking the main line. Small details like this can make a huge difference in rail efficiency, especially once traffic increases. In the next shots, we return to the mining complex to refine the layout and fix a few imperfections. One of the first adjustments is repositioning one of the steel mills so it sits parallel to the other. This simple change makes the whole design more compact, more efficient, and visually cleaner. Small alignment tweaks like this may seem minor, but when working with large industries, they can dramatically improve both space usage and logistics flow. After that, I continue optimizing some of the rail splits and connections. The goal here is not just functionality, but realism and structural clarity. Clean rail geometry helps trains move smoothly, reduces pathfinding issues, and makes the entire system feel more believable. Now, as I hinted earlier, it's time to revisit the coal delivery system. Instead of sending coal directly to the steel mills, I decided to redesign the system around a centralized unloading station. This approach has several advantages. First, it allows coal to be stored locally. Second, it opens the possibility to use that same supply for additional infrastructure. For example, this coal reserve could later support a heating plant for the nearby city, or even a power plant to supply electricity to the industrial zone. Designing infrastructure with flexibility like this makes expansion much easier in the long run. The unloading terminal will include 2 separate waiting tracks for coal trains. This allows arriving trains to queue safely without blocking the main line, which is essential for maintaining steady traffic flow. Construction has begun, demonstrating the importance of the helicopter construction office and what a time saver it is. Thanks to the speed of helicopters, materials can be delivered to sites much faster. The construction of the railway line is also progressing rapidly, which is of great importance as this will be the main means of transporting large volumes of cargo to and from the complex. Next, we begin work on the electrical grid. This includes placing both high voltage and low voltage transformers to prepare the area for industrial power demand. The 2 steel mills are connected directly to high voltage lines. This prevents them from overloading local infrastructure and keeps the rest of the grid stable. Now we need to plan the low-voltage network for the complex. I hope that the capacity will be sufficient to serve all buildings and facilities. But even if there is a problem, there are additional outputs to provide backup if necessary. As you can see, the main factor is coverage, since I can't see the estimated consumption right now. I think now is the ideal time to integrate the city's heating plant into the layout. Of course, this is one of the buildings that will be constructed at a later stage, as there is no need for it at present. Since this is a facility of exceptional importance for the city, I will build a separate coal storage. At this point, we briefly shift focus to one of the villages close to the oil field. This settlement was actually built quite a long time ago, but only now I decided to run a small experiment. I want to see whether a town can function entirely without public transport, relying only on private cars. Besides the experiment, there's also a practical reason. This village will supply workers for the nearby power plant, which will soon become even more important once the steel complex is fully operational. After that short detour, we return to power infrastructure, this time focusing again on high-voltage transmission. We begin placing the long-distance power lines that will connect the complex to its energy source. For now, the entire industrial zone will rely on a single power plant located near the village we just visited. This makes the stability of that plant critically important for the success of the whole project. Thank you all for watching this episode. If you enjoyed the video, don't forget to leave a like and subscribe for more episodes in this series. You can also become a member to support the channel and future projects. More progress is coming soon, and I'll see you in the next video.